Welcome, algebra students, to our video on writing equations for word problems. And this is one of my all-time favorite memes right here. How I see math word problems. Now, obviously, this is not me because I can handle math word problems because it's my job, and I better be able to handle math word problems, but this has always been one of my favorites. If you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? And the answer is purple, because aliens don't wear hats. I'm sure you've seen this before, but it is one of those that it kind of cracks you up. Anyway, we're going to be writing equations for word problems, and I know some of you are going to be upset by this, but the equation is the goal, not the solution, because we need to work on the actual writing equations. And I'll have another meme for you at the end of the video that will kind of explain why. All right, starting with when we're translating, the word is means equals. Okay, it could be any derivation of the verb to be. So it could be was. It could be any verb, any verbal phrase, any verb phrase, not verbal, but verb phrase that tells you that is a derivation of the verb to be. Okay, so if something is something else, that's what we're talking about when we talk about is meaning equals. So we're going to translate a couple of equations now, not just expressions. Twice a number decreased by 29 is 7. Twice a number decreased by 29 is 7. So first I want to talk about that is 7. So equals 7. And that's the first thing I want you to have in mind here, that the is the equals. Now we'll write the other side of the equation. Twice a number decreased by 29. Not hard at all. Twice a number, so 2n decreased by, subtract 29. 2n minus 29 equals 7. How about the other one? The next one, I should say. 32 is 1/2 of a number increased by 8. So this time we've got 32 is. We've got our is there on the left-hand side. Or we've got our number on the left-hand side, so we have our is right at the beginning of the sentence. Is. 32 is 1/2 of a number. Remember, that's half of is half times. No dot, no parentheses. Get out of that habit of using the extra pencil lead. Increased by, so we're adding, increased by what? Increased by 8. All right, next one, or last one on the page. The quotient of 5 more than a number, the quotient of 5 more than a number and 50 is 10. So is 10. I like that part. I'm going to do that part first. The quotient of, so we're dividing. Quotient of what? 5 more than a number and 50. So 5 more than a number is n plus 5, and that's going to go on the top because quotient goes in the order in which you see it in the problem, top to bottom. 5 more than a number and 50. So when we're translating, once more, is to be, that verb, that verbal phrase, that is telling you the equals part of your equation. Let's try some that are practical problems. Now, before you start any one of these problems where I tell you to write an equation for the problem, the first thing you need to do is define a variable. Does that mean we write down the word variable and write down a definition? A number that represents, or a letter that represents a number. No, it does not. What it means is that we write a brief description of the unknown. And that's going to be aggravating for some of you again because look, it's so easy, I know the answer. But that's not the point. We're learning about how to organize this thinking, how to organize the abstract thought into equations. Jeannie has $17 in her piggy bank. How much money does she need to buy a video game that costs $68? And I'm going to use n to represent my variable. This is what defining a variable is. N represents money Jeannie needs. And I'm not writing Jeannie's entire name out. Maybe her nickname is Jay. Who knows? All right, so she has 17. She needs money to get a $68 video game. The video game is $68. So you think about that costs, that's the telling you that the video game is $68 there. And there's your equation. And again, I'm not worried about the solution. I'm worried about the equations. Okay, so we've got to be able to write them and recognize them. 2/3 of the students in the 7th grade participated in the after-school activity. If 74 kids were there, how many kids are in the 7th grade? Now remember, start with your variable. N, number of kids in the 7th grade. Okay? 2/3 of the students in the 7th grade, that's n, so 2/3 of, and of means times, 2/3 of n participated in the after-school activity, and that was 74 kids. And there's our oh, hey, no, not 75, 74. 74 kids. Again, not very complicated. Not very complicated because we have a circumstance we've got written out. But this might not have been as easy to do in your heads. I know a lot of you can handle it, but some of us aren't built to think that way. So the equation gives you a visual and it gives you a method for doing the problem. Okay, that's the goal. Remember, here is the equation, not the answer. Next problem. Now on to a couple of specific types of problems. So perimeter problem. So perimeter, we're talking about geometry here. The length of a rectangle is 6 more than its width. If the perimeter is 24 inches, what's the length of the rectangle? Well, defining a variable in this case is actually best done by drawing a picture. So I'm going to put p equals 24 outside my rectangle. When you are defining something like this, you want to build to define. So you've got length and you've got width. And based on the description, the width is the smaller one. The width is less than the length. Everyone always says, well, width is supposed to be less than length. Yeah, not necessarily. It just depends on how you decide to hold whatever the rectangle is. But in this case, the width of this is the smaller one. Make that your variable. Build on that for the other one. And then think about what you're talking about with perimeter. The perimeter is 24. We have to add all 4 sides. So we have 2 of the width plus 2 of the length. Now, we haven't solved any equations this video so far. Let's solve this one. I'm going to distribute the 2. I have 2w plus 2w plus 12. I need to combine some like terms. And then we reverse our order of operations. Subtract the 12 first. 4w equals 12. Divide by the 4 second. W equals 3. But be careful, that's not what we're looking for. We're looking for the length of the rectangle, which is going to be 3 for W plus 6. 3 plus 6. So the length is 3 plus 6, 9 inches. And that's a perimeter problem. Be prepared to see more of those in class. And finally, we have 2 consecutive integer problems. The first one, the sum of 3 consecutive integers is 147. Find those integers. First of all, what does consecutive mean? It means one right after the other. 2, 3, and 4 would be consecutive integers. Clearly, they're not the ones we're looking for because they add up to 9, so not 147, but bear with me. Now, you may have a backwards way of doing this, and that's fine for solving a problem, but I'm asking you to write an equation. So we've got to define a variable, and we're going to do that verbally this time. Last problem, it was better in a diagram. I'm going to define x as the first integer. I'm going to define the next number after x as x plus 1. And I'm going to define the third number after x, or the third number in a row here, as x plus 2. We can't say x plus y plus z. We don't know how to solve an equation with 3 variables yet. But we can say x, x plus 1, and x plus 2. The sum of those 3 numbers is x plus 1 plus x plus 2, and it equals 147. So now I can combine like terms and solve. So 3x plus 3 equals 147. Subtract the 3 from both sides, and we have 3x equals 144. Divide both sides by 3. I'm moving up here because I'm out of space. Divide both sides by 3. Excellent chance to review short division. 3 goes into 14 4 times with 2 left over. 3 goes into 24 8 times. So 48 is the first number. 49 would be the next one, x plus 1, 48 plus 1, and 50 would be the third one. And those are our 3 consecutive integers for this problem. Let's do another consecutive integer problem with a little bit of a twist. This one says the sum of 3 consecutive odd integers is 147. Find those integers. We're going to start the same way. Okay, your music will come back in a minute, but there's a Macy's ad on, and I'll be darned if I'm giving them free advertising. Oops, I did it again. I told you who it was. Oh, well. You can go to Macy's if you want. whatever. Anyway, 3 consecutive integers. So x is my first integer. Now, these are consecutive odd integers. What's the next odd number after x? If x is odd, where do you have to go to get to the next odd number? Well, you have to go up by 2. Because 5, the next odd number would be 7. The next one would be 9. They're 2 apart. They're 2 apart. Add 2 each time. So if x is the first integer, x plus 2 is the next odd number, and then x plus 4 would be the next number after that. And again, the sum of those 3 integers is x plus 2, and x plus 4, and it equals 147. And once again, combine like terms, 3x plus 6 equals 147. And I'm going to have to leave this and come back to it in about an hour and a half because lunch is over. I'm trying to rush around and get things done during the time periods that I have. I'll come back to this video in a little while and continue with this problem and finish off the video. And while you don't even see a difference between a second ago and now, it's actually been an hour and a half, and I'm going to finish this up now. All right, so we have to divide, but getting back in the swing of things here. Reverse our order of operations. Addition or subtraction first, in this case, subtraction. Coming up here for lack of space. 3x equals 141, and you might think, oh, man. Oh, wait, is that right? Yeah, that's right. Duh. 3x equals 141. We're dividing by 3, and again, a great chance for short division. 3 goes into 14 4 times with 2 left over. 3 goes into 21 7 times with none left over. So 47 is my first number. And remember to add 2, 49, and add 2, 51. And our 3 numbers are 47, 49, and 51. And we worked on writing our equations, and we did a couple of solving. So you're going to be seeing problems like these in class to translate and to probably then solve. So this is just a quick reminder of what's actually going on here, because we see plenty of memes of, look, another day went by and I never used algebra. Yeah, we know. You're not going to actually be writing equations and solving them unless you work in a field where that's acceptable, or if you become a math teacher, which would be awesome. My least favorite math teacher of all time in high school used to tell me I'd make a great math teacher. Please don't anyone go tell Roberta Thompson at Manchester High School that I'm a math teacher. I don't think she's still there. She's probably retired by now anyway. And for those of you wondering, Manchester is Manchester, Connecticut. Anyway, this is why we learn algebra, folks. What if I told you that the purpose of learning algebra is not to do algebra, but to learn how to think? We're trying to teach you how to think abstractly, folks, not just solve equations and all of that, and that's why we have to be able to write these equations. So that's the skill we're working on. I'll see you in class.